Example 1, finding critical values for the F distribution part B. Now for a two-tailed test with alpha is equal to 0.05, degrees of freedom in the numerator is equal to 15, and the degrees of freedom in the denominator is equal to 20. If we have a two-tailed test, that means we're going to have two critical values. So in step 1, we need to see what happens with this figure. So figure 18 is going to show the F distribution with 15 degrees of freedom in the numerator and 20 degrees of freedom in the denominator. Now the area to the right of the right critical value is going to be alpha divided by 2. And alpha, which is 0.05, divide that by 2 is going to give us 0.025. So we denote this critical value as F 0.025, 15 degrees of freedom in the numerator and 20 degrees of freedom in a denominator. Now, the area to the right of the critical value, in this case to the left of the critical value, so from here to here, is going to be 1 minus alpha divided by 2. Well, alpha divided by 2 is 0.025. So 1 minus 0.025 gives us an area of 0.975. So we denote this critical value over here on the left side as F 0.975, 15 degrees of freedom in the numerator and 20 degrees of freedom in the denominator. Now, again, this is the only reason why that we have two critical values is because this is a two-tailed test. Now we're going to refer to table 9 to find the right critical value and identify the column that represents 15 degrees of freedom, which is the numerator degrees of freedom, and the row that represents 20 degrees of freedom, which is the denominator degrees of freedom, with alpha divided by 2, since this is a two-tailed test, which would equal 0.025. So what we want to do is we want to find the right critical value. In order to find the right critical value, we need to use the area, which is 0.025. We add the degrees of freedom in the numerator, which is 15. Degrees of freedom in the denominator is 20. So let's go ahead and look down at this chart here. So we know that we're dealing with the area of 0.025, and we can see that the degrees of freedom in the numerator is 15. And then we can see the degrees of freedom in the denominator is 20. So what do we notice here? We can see that the critical value is now going to be 2.76. So the critical value over here represents 2.76. So that gives us our critical value where the area to the right is 0.025. Now we want to look from here to this side to get this critical value over here. So we're looking at F 0.975, 15, and 20. So what we can do is, in order to find the critical value of we have 2.76. So we're going to see that the left critical value is going to be 1 over 2.76. And 1 over 2.76, if we use our calculator, let's go ahead and do that. So we got 1 divided by 2.76, and that gives us 0.36. So now we can say that this number over here is 0.36. And therefore, we have found our critical values of a two-tailed test.